Okay, in this video, I'm going to go through the homework for 6.1 so we can get ready for our quiz. So here we go. So when we are talking about similar shapes, you need to know that, for one, right here, this is a similarity statement. This symbol means similarity. In order for shapes to be similar, they're going to have congruent corresponding angles. So look at this similarity statement. Angle A is going to be equal to angle D. So first equals first, middle equals middle, and last equals last. So you can either put a congruency statement, you can either put an equal sign rather, or a congruency symbol, which has a little tilde. It has this little shape on top of the equal sign. Okay, next thing. In order for two shapes to be similar, their sides are not going to be equal, but their sides are going to have the same proportion. That means fractions. Okay, so look at your statement. AB are the first two letters. DE are the first two letters in the second shape. So AB over ED, that proportion is going to equal BC, which is the second two, over EF, which is the second two, and then AC, which is first and last, and DF, which is first and last. So once you have these, you can say, oh yeah, AB is in proportion to ED, just like BC is in proportion to EF, just like AC is in proportion to DF. Okay, you've got to be able to write that, and both of these things have to be true. So the angles have to be equal to their corresponding angles, and the sides are in proportion to their corresponding sides. Now, when I have numbers involved for the side lengths, I can get a scale factor, because I'm going to take all of my fractions and put them in simplest terms. That's still coming. Let's go to the second problem. Same idea there. Use your similarity statement. First angle is to first angle, just like second angle equals second angle, and third angle equals third angle. First two letters are a side, is in proportion to the first two letters of the second shape. Second two letters are in proportion to the second two letters, and first and last over first and last. Okay, when you have four sides, so that's a quadrilateral shape, you're going to have four pairs of angles that are congruent. Again, we're going to use the similarity statement to get our angles. So first angle is to first angle, or equals first angle. Second angle equals second angle. Third angle equals third angle. Fourth angle equals fourth angle. We're going to have four sets of fractions here. So the first two letters over the first two letters of the second shape. The second two letters, D and E, over J and K. The third letters, EF over KL, and first and last over first and last. Okay, the same thing goes with number 4. Make sure you can do this and that you understand that this is what's required to prove that these shapes are indeed similar. Not congruent, but similar. Okay, so then now they ask you to determine whether the polygons are similar. So first thing you do is check your angles. This is a single, that goes with that single. This is a double, it goes with that double. This is a right angle, it goes to that right angle. The corresponding angles are indeed equal. Now figure out your proportions. Okay, so the side between the right and the single is going to be the numerator of the fraction here, and then the side between the right angle and the single is here. Okay, then the side between the single and the double, 5, over the side between the single and the double, 10. The side between the right angle and the double, 4, over the side between the right angle and the double, 8. Okay, are these all the same? Well, I can reduce each of these to 1/2. Okay, 3 goes into 3 one time, 3 goes into 6 two times. That makes this 1/2. 5 goes into 5 one time, 5 goes into 10 two times. It makes that 1/2. 4 goes into 4 one time, 4 goes into 8 two times. It makes this 1/2. This is your scale factor. It's in simplest terms. Because I have same proportions and congruent angles, I can say yes, these are indeed similar shapes. To get your statement, line up your angles. If I'm going to name the first triangle as ABC, that's right, single, double marks on my angles. Then I should have put a little triangle here. And then this is going to be right, single, double in terms of your markings. Okay, look at the next one. When I look at the next one, I have similar, 2 angles that are the same. So J and N are the same, I and M are the same, H and L are the same, and G and K are the same. So therefore, it meets the requirement of having congruent corresponding angles. Now let's check the proportions. Look at all of these. I only have 2 numbers. I have 6s and 9s. Over here, I have 4s and 6s. So over here, take the smaller of the numbers. So that's 6 over the smaller of the numbers here, which is 4. That has to equal the biggest of the numbers, which is 9, over the biggest of the numbers here, which is 6. So look, I have 6 over 4 is possibly equal to 9 over 6. Both of these fractions can be reduced to 3/2. I get that by taking 6 divided by 2 is 3. 4 divided by 2 is 2. 9 divided by 3 is 3. And 6 divided by 3 is 2. These both reduce to 3/2. That's my scale factor. I therefore have congruent angles and sides and proportions, so I have similar figures. Let's name your shape. I went single, double, double, single, which was JGHI. So I'm going to go single, double, double, single, which is NKLM, and that's the correct way to write that. Okay, that brings us to 7. Now look what happens to 7. Oh, and I should say one more thing. Let's go back up here for a second. Let's say you didn't want to reduce them. To see if these proportions are the same, do your cross products. Is 6 times 6 the same as 9 times 4? And the answer is yes, because 6 times 6 is 36, and 9 times 4 is also 36. So yes, because the cross products are equal, I know that these fractions can be reduced to the same scale factor, and my shape is similar. Okay, now let's go down to 7. So I see that I have all right angles. So I can say, yes, I have corresponding angles that are congruent. So my next thing is to go for the proportions. On the left, take the biggest proportion, or biggest value, which is 8. So 8 is to biggest value here, which is 6, possibly just like littlest value here, which is 6, over littlest value here, which is 3. If I did cross products, look what happens. 8 times 3 is 24. 24. That does not equal 6 times 6, which is 36. So I know right away, because my cross products are not equal, I do not have similar shapes because my sides are not in proportion. Okay, I thought 8 was very interesting because look what we have. Check out the angles. B is exactly equal to D, C is equal to E, and A is equal to F. So I know I have corresponding angles that are equal, and therefore it's a candidate for similarity. Now let's do this. Take the biggest side here, which is 12, over the biggest side here, which is 12, the medium here, which is 11, over the median here, which is 11, and the smallest, which is 10, over 10. These are all equivalent to 1 over 1. So the scale factor is 1 to 1. So notice, not only are these shapes similar, they are actually congruent because they're exactly the same. So if your scale factor is 1 to 1, you have identified congruent shapes. So they're similar and they're congruent, and that will rarely happen. Let's go on down to number 9. Okay, so here we're going to try to find missing pieces. So they are saying to us by this statement that these two shapes are indeed similar. So they want us to find the value of x. So you don't need to prove they're similar. They are telling you they are. So therefore, I'm looking for x. X is here. X is PR. So see if you can line up a proportion. So ST is 6 and PQ is 4. So 6 is to 4. What goes with x? If x is PR, that's first and last. So SU is first and last here. So that means that 6 over 4 has to equal 12 over x. So here's our cross products. You can get the missing side by saying 6 times x equals 4 times 12, which is 48. Divide both sides by 6, and you get x equals 8. And that's how you find a missing side using your cross products. So let's try find another one. So look at 10. 10, what do I see? They gave me DE, which is 8. And do I have an MJ? Well, I do, because these are rectangles, or these are quadrilaterals, or parallelograms, I guess. So 12 is here and 12 is there. So if I know DE, which is 8, then I know MJ has to be 12 because KL is 12. So what I'm doing is I'm saying 8 over 12, and then let's see what we have. We have CE, which is first and second and third. Do we have LM? No, that's what we're looking for. Okay, good. So I'm going to say 8 is to 12, just like 12 is to x. Now, instead of doing big numbers, why don't I try to reduce this? So 4 goes into 8 2 times, 4 goes into 12 3 times. Now do your cross products. It'll be small numbers to work with. 3 times 12 is 36 equals 2 times x, because you're doing cross products. Divide both sides by 2, and we get x is 18. So that's how I find the missing side using the scale factors. Okay, this is the last topic you need to know for this quiz. When you have similarity, you also have the scale factor that you can determine. The scale factor tells me how the sides relate to the sides. They also tell me how the perimeter of one shape relates to the perimeter of the other shape. They are also in the same scale factor. So let me show you what I mean. Let's see if we can get a scale factor. The only number I have to the triangle to the right is 12. That's PQ. PQ. Put 12 in the denominator because it's the triangle to the right. The triangle to the left goes first. Just like you read from left to right, you look at these triangles from left to right. So PQ matches what? PQ matches LM. LM is 9. 9 over 12, can I reduce that? And I can. I can put 3 into 9 3 times and 3 into 12 4 times. Here is my scale factor. The scale factor of the first triangle to the second triangle tells me that the perimeters will be in the same proportion as the sides. So can we figure out the perimeter of the triangle to the left? We can. If we add 15 and 9 and 21 together, we get 45. So scale factor, 3:4, that's the triangle to the left, is to the triangle to the right, just like a perimeter of 45 to the left equals a perimeter of some unknown value to the right. Do your cross products. 4 times 45 gives me 180. 180 equals 3 times P. Divide both sides by 3. 3 goes into 180 60 times. The perimeter to the right will be 60. Okay? Just to recap, the sides of the similar triangles and the perimeters of the similar triangles are in the same proportion. They share the same scale factor. Okay, one last one. Okay, so here we have these two shapes. Again, we're going to read from left to right. They are telling you that they're similar. I see only one number here. It's ST. So ST has to match with XY in terms of proportionality. So ST was 21, XY is 35. This is a big number. To get the scale factor, I'm going to reduce it to simplest terms. I'm looking at 21 and 35, and I'm saying 7 goes in both of these numbers evenly. 21 divided by 7 is 3. 35 divided by 7 is 5. 3/5 is my scale factor. So that means that 3/5 will equal the perimeter of the triangle to the left over the perimeter of the triangle to the right. Since I have all 4 sides in the right, I can add them up right here, and I get 100. 100 is that perimeter. 100 goes in the denominator. 3/5 equals the perimeter to the left over the perimeter to the right. Do your cross products. 3 times 100 is 300. P times 5 is 5P. Divide both sides by 5 to get P by itself, and you should get P is 60. The perimeter of the smaller shape is 60. Okay, so those are the topics you have to understand about similar shapes, not only just triangles, but similar quadrilaterals as well as similar triangles. Okay, you want to know that the angles in similar shapes are congruent. The sides of similar shapes are in proportion. When you reduce that proportion to the simplest terms, that is called the scale factor. Not only are the sides in proportion, but the perimeters are also in proportion. And that's what we did in the last 2 questions. I hope this helps.